So, hello everyone. Hello everyone. I'm very happy today. My talk titled Keycloak's updates on emerging paradigm of identity and also compliance with some security specifications. So before my talk, let me introduce myself to you.
Somebody has the speaker on. Okay. Do we have another browser window open?
I see. So sorry. I open. Yes, I opened the browser maybe. So
Good.
sorry. It's my mistake. I'm very sorry. I forgot to open my browser. Is that okay?
That's okay.
Okay.
Oh.
So resume my presentation. So sorry. I'm Takashi Norimatsu, the Keycloak maintainer and also working for C Limited channel. I have been mainly contributing security features and helping other contributors work to Keycloak since 2018. So for example, the following item shown on this slide, Web Authentication API and some RFC, PXC, eIDAS, and FAPI, Financial Growth API Security Profile, and so on. And so today, maybe I'd like to talk about the main two topics. The first topic is about the emerging paradigm of identity. That is related to the eUDI warrant described on the keynote. And the second topic is about the compliance with security specification. The Keycloak said you may hear that the Keycloak supported some security specification like RFC, the OAuth 2, OIDC, and so on. So what the supporting the specification means. And also, in this talk, I'd like to list up the specifications that current Keycloak supported. So let's move on to the first topic, the emerging paradigm of identity. So maybe the European citizen may hear the word the EUDI warrant described in today's keynote speech. EUDI warrant to read the personal information or any related attribute or person as verifiable credentials called VC. So the W3C defines its data model. In this data model, mainly there are four major roles: the issuer, holder, and the subject, and verifier. So the subject holds this called wallet, and issuer issue the verifiable credentials VC to the wallet. These PC include the personal information about this subject and also some attribute about this subject. Then the wallet present the verifiable presentation to verifier on behalf of the subject. So these verifiable credentials consist of one or several verifiable credentials. The main point on this data model is that verifiers do not need to access the issuer when verifying this verifiable presentation. So for example of this use case, I'm not 100% sure, but that the issuer might be the government agency issuing the passport. The VC is something like the digital passport, and the wallet present verifier In this case, the verifier might be the passport control on the international airport. Then there are several open standards for VC as described in today's keynote speech. And also there are several protocols for issuing and presenting the VC. Then the Keycloak is now working on supporting one of such protocol called OpenID for Verifiable Credential Issuance called OID for VC. The motivation for supporting this protocol is that if Keycloak can support OID for VCI, then Keycloak should be used on issuer an eUDI wallet ecosystem. The European Commission released the documentation called ARF, Architecture and Reference Framework for eUDI wallet and its ecosystem. This documentation describes that the OID issuer need to implement the OID for VCI. So I'd like to talk about the current Keycloak support for OID for VCI. This support could be achieved by the Keycloak contributors. The latest version of the Keycloak, maybe the Keycloak 25, have already supported OID for VCI partially. And the current this support is treated as experimental feature. And also please note that this support followed the OID for VC's implementers draft version 13. Then, as far as I know, the latest version of this OID for VCI specification is draft 14. So therefore, we need to track the latest version of the OID for VCI specification in the future. Then, the OID for VCI specification defines two types of flow for VC issuance. Pre-authorization code flow is original for VC specification, and authorization code flow, that's from the normal OAuth specification. Then the current Keycloak 25 only support pre-authorization code flow for VC issuance. But however, maybe the next version, Keycloak 26 or the later version, can support authorization code flow for VC issuance. Then, OID for VC specification defines three ways of which VC is to be issued. Convey this information from holder, namely the wallet, to the Keycloak as an issuer. The scope authorization details into issuer state parameter of authorization request. Then, the current Keycloak only support scope parameter for this purpose. So also the OID for VCI specification defines three types of variation for VC issuance: immediate, and deferred, and batch credential issuance. Then the current Keycloak only support immediate credential issuance. And also OID for VCI specification defines two types of credential offer: the same device and cross device. You can use this same device credential offer by Keycloak 25. And you may also use cross device credential offer by Keycloak 25, but however, you need some tweak for using cross device. Then the OID for VCI specification does not depend on any specific VC format. But however, this specification lists up some candidate for that format. SE.VC by ITF and .VC by DIF, the RDVC by WCC, and mobile driver license by ISO. Then the current Keycloak support ST.VC defined by ITF. This slide shows the layout of the component about OID for VCA support. Please note that the next version or the future version of the Keycloak implementation for OID for VCI may drastically change. So therefore, please note that this layout may be only applicable to current Keycloak version 25. Maybe in the future, this layout might be changed. Then the realm hold the issuer DID as realm attribute. This issuer DID is put onto ISS claim in SSJPC. And realm hold some signing service provider. This provider put a signature onto VC by using the Keycloak realm key. Then the realms have several clients for OID for VCI. This client is different from the OIDC client and some client, the original types of client. These clients hold several credential configuration. Credential configuration defines which VC is to be issued. And this OID for VCI client hold some dedicated protocol mapper that correspond to the credential configuration. This protocol mapper actually put an issue onto VC. This slide shows an example of a signing service provider or ST.VC. This service provider are the same as for the other provider. It can be represented as the realm component. This slide shows some example of the OID4 VCI, the credential configuration. So please note that the Keycloak credential configuration can be represented as the JSON and also hierarchized by dot. For example, in the right side of this slide, in the client's attribute, the VC dot test credential dot da da da, and also VC dot identity credential dot da da da. This test credential and identity credential correspond with some kind of the ID for credential configuration. So we can translate this hierarchized Keycloak-based JSON format onto the formal JSON representation shown on the left side of this slide. This slide shows an example of some relationships between OID4 VCI components. The right side of this slide shows the credential configuration example in the client attribute. And the right side of this slide shows the protocol mapper for this credential configuration. And finally, the digest in the JVC is shown on the below on this slide. Then this protocol mapper would claim the name identity credential of supported credential types frame onto the digest of ST.VC. This slide shows an actual example of ST.VC actually issued by Keycloak 25. I just mentioned before, on this slide, left side of this slide, the ISS claim states that issuer DID is a realm attribute. So in order for you to issue VC by using this Keycloak support, you need to do the following step. You need to register the issuer DID as realm attribute and need to register signing service as realm component model. And you need to register the YG4VC client, and you need to register the credential configuration for this client. And you also need to register the float promoter for this client on step 3. Then you need to do the following step by admin CLI or admin REST API access directory. Currently, you cannot use admin console for doing these steps. Keycloak cannot support that. From this slide, I would like to talk about the specific details of how VC is issued by following authorization code flow. But please note that this authorization code flow for VC assurance has not yet supported by the latest Keycloak version 25, but maybe supported in the next version or future version of the Keycloak. Then, so as just mentioned at the beginning of this talk, there are 4 types of major roles around VC, holder, wallet, and issuer verifier. Then that can be corresponding with the role in the OAuth2 context. Holder as OAuth2 resource owner, wallet as OAuth2 client, and credential issuer as OAuth2 resource server, and token issuer used for accessing getting this credential. Token issuer as OAuth2 authorization server. Then the Keycloak plays 2 roles, both roles, token issuer and credential issuer. So at first, you have a holder, your wallet as a client. So at first, you need to register the client configuration for your wallet as follows on step 0. The credential configuration supported. Its ID is thread02 and its scope parameter value is scope 02. After that, your wallet need to get credential issuer metadata or Keycloak as a credential issuer. Then after that, your wallet need to choose one credential configuration. Keycloak only supported, currently Keycloak supported only selecting one credential configuration. So in this slide, we choose the cred 02. After that, your wallet need to send authorization request with scope parameter whose value is scope 02. That is corresponding with thread 02 credential configuration. After that, you yourself do authentication and authorization. After that, your wallet get an authorization response with authorization code flow. After that, your wallet send access token request with this authorization code. And finally, the folder gets an access token that is used to get VC. And finally, the folder gets an VC in return for this access token. Then on this side, I'd like to test you the brief roadmap for the VC support by Keycloak. And as just mentioned before, the current Keycloak version 25 supported YG4VCI. However, it's treated as experimental feature, and therefore the current Keycloak does not completely follow the YG4VCI specification. So therefore, we need to make this support to be preview future, and finally to be officially supported future. So mainly, the main contribution for this OID for VCI have been conducted by activity in OAuth SIG that Vinod told just before the session. So we would be very happy if you participate in this work to refine OID for VCI support by Keycloak in the future. So the last half of this talk is about compliance with security specification. So Keycloak have already supported several security specifications or host 2, OIDC, and so on. Then, but what supporting the specification means. So in my opinion, implementing the features as the specification describes. But however, how we can check whether the software component, the software implementing security specification, implement this feature by following this specification. So in my opinion, it might be better for us to get a conformance test from standardization body and run this conformance against software product like Keycloak and confirm that Keycloak passed this conformance test. And it might be best for us that the Keycloak that's certified by a standardization body of the specification. Some standardization body provide certificate program. For example, the NIST, BIPS, File Alliance, File 2, the OIDF, OIDC, and FAPI, and Open Banking Security Profiles. Then, so not all standardization body provide conformance test for their specifications. So if we cannot get this conformance test from the standardization body, how can we check whether Keycloak supports the specification? Then, in my opinion, the contributor needs to write a self-integration test by themselves and confirm that Keycloak passed the conformance test. Now, considering that point, in my opinion, there are several levels of assurance of conformity, from low conformity to high conformity, pass self-integration test, pass conformance test, and that's certified by standardization body. Then also please note that this slide describes and what I talk to you are not a Keycloak project brochure opinion. This slide shows the security specifications that Keycloak got certified by OpenID Foundation. And also in this slide, shows the security specification defined by OpenID Foundation, but however, number 15 and number 16, copy 2.0, Keycloak, we confirm that Keycloak has conformance test provided by OpenID Foundation, but however, not yet get certified by OpenID Foundation. Then the number 17, OpenID for Verifiable Credential, namely OID for VCI. As far as I know, the OID has not yet provided conformance test for OID for VC. So therefore, we confirm that Keycloak passed self-integration test written by contributors. I would like to skip the details about that. If you are interested in this topic, please refer to the slide. Maybe you can download this slide. Maybe. So this slide shows the open banking specification that Keycloak got certified by OpenID Foundation. You may not heard about the open banking. Open banking is an ecosystem that provides where the financial institution like bank provide their financial services via APIs. Then third-party application access to the API on behalf of the end user of this application to get some kind of financial services. Several open banking ecosystems exist in the world. So Brazil, UK, and Australia, and so on. Keycloak got certified Brazil Open Banking Security Profiles by OpenID Foundation and also Australia Consumer Data Rights Security Specification. And Keycloak has conformance test for UK Open Banking Security Specification, but not yet got certified by OpenID Foundation. Then, so this slide shows the specification about OAuth 2 itself and it's the OAuth2 related security specification standardized by IETF. Then, so as far as I know, the IETF does not provide this conformance test for this specification. So therefore, we confirm that the Keycloak has self-integration test written by contributors and confirm that Keycloak passed this self-integration test written by contributor. Also this slide shows the same. Then the Keycloak also supported security specification standardized by other than IETF and OpenID Foundation. For example, the user-managed access by Kantara Initiative and SAML v2 by OASIS and Web Authentication API, WebAuthn by W3C and NIST FIPS 140. Then as for this specification, some standardization body provide performance test and also provide a certificate program. For example, the Filed Alliance provide a conformance test and a certificate program about Filed2 that are related to WebAuthn, Web Authentication API specification. But however, the Keycloak we only confirm that the Keycloak passed self-integration test written by the contributors, not the conformance test provided by standardization body. Okay, so to wrap up my talk, in the first part of this talk, we told you the current Keycloak version 25 OID for VCI, OpenID Connect, OpenID for Verifiable Credential Issuance support in details and provide some brief roadmap for OID for VCI support about OID for VCI support by Keycloak. Then the last part of this talk, I told you the security specification that Keycloak supported. However, I also told you the meaning of what supporting some security specification means and propose some level of assurance of conformity and also provided the list of security standards that current Keycloak supported. So, okay, that's all my talk. Thank you very much for your listening.